Welcome, ladies and gentlemen, to our Science Industry Talk 2021. I'm very glad to have you here, at least online. These days, groups of many people in one venue is a picture we can't even really think of, possibly dream of these days. The pandemic's grip is not getting any looser. The news can easily be mixed up with a very dystopian movie. And it rarely happens that, as much as in a pandemic, it shows how much better and more cooperation is needed between science, politics, and business. And I'd like to add media. My name is Rosa Lyon. I work as a journalist for ORF. I host the Zeit im Bild at lunchtime, and I'm a reporter for TV and radio. I originally studied economics, but now reporting includes worldwide happening, not only economics. We have a threefold official opening of today's event. Thomas Henzinger is with us, Peter Koren and Heinz Fassmann, science, business, and politics all in one. Thomas Henzinger holds a PhD from Stanford, and he is the president of IST Austria since the year 2009. Please officially open this year's Science Talk.
Thank you. Welcome to everyone. Also from my side, I especially welcome the keynote speaker and all our distinguished speakers and panelists. Thank you for joining us digitally today. This year, the annual Science Industry Talk takes place for the 14th time, always in cooperation with the Federation of Austrian Industries. It is a day about technology transfer, how scientific results can create value for society and for industry, and about forming new connections between science and industry. Over the past 2 years, we've had the chance, front row, to witness how critically science contributes to human well-being. In the same 2 years, the IST Park next door to IST Austria established a growing community of technology startups, entrepreneurs, and biotech companies. And together with IST's technology transfer subsidiary Twist and the IST Cube Venture Seed Fund, we strive to provide a small but complete and highly effective ecosystem for innovation. The importance of this topic is further highlighted by the appointment of a vice president for technology transfer at IST Austria just a few months ago. You will see Bernd Bickel, who is also professor for computer science at IST Austria, later in the program. Tonight, we want to survey some of the achievements and the progress on the topic at and beyond IST Austria. We also want to explore the question how IST Austria and other similar institutions can further improve the translation of scientific insights into economic and societal benefits. In parallel sessions, you will have the opportunity to meet both scientists from IST Austria and tenants of the neighboring technology park. You will hear about state-of-the-art developments in the life sciences, in computer science, and in physics and chemistry. And you will see how some of our cutting-edge research is already on the way towards commercial impact. Both in our multidisciplinary mindset and as frontier research institution, IST Austria contributes uniquely to the empowerment of the Austrian economy. With this in mind, I'm welcoming and handing over to Peter Koren, the Deputy Director General of the Federation of Austrian Industries. Peter.
Thank you very much, Thomas Henzinger. dear researchers, dear students, distinguished guests. It's a special honor for me to welcome you on behalf of the Federation of Austrian Industries to this year's Science Industry Talk. We look back with pride on our long-standing cooperation with IST Austria. And as Thomas already said, IST has become a beacon of the Austrian research landscape and of international cutting-edge research. The research successes of your scientists from all over the world also speak for themselves. The enormous success rate of ERC grants is really outstanding. In this context, we are very pleased with the recent long-term agreement on the budgetary basis until 2036. Congratulations to you and your team, President Hensinger, and many thanks to the Minister, to the Ministry, and also to the government of Lower Austria. Today's Science Industry Talk will focus on technology transfer and the scientific achievements. For our industry, for Austria's industry, the successful transfer of knowledge and technology between science and industry is a particularly important concern. To tackle the complex challenges we face as a society, from pandemic to digital transformation and climate change, to name just a few, we need intensive and ongoing cooperation between science and economy, and of course, politics. First of all, we need a proactive approach to technology transfer. This is possible in many ways, through heads, structures, and through common areas of strength. For the transfer of scientific findings into society, or in our case, into the market, it is also important that young, innovative technology startups receive the support they need to be successful in the international environment. At ISTA, you have already demonstrated how it is possible to increase the number of deep tech spin-offs with the IST Cube. In light of your outstanding role in knowledge transfer, we are pleased to be able to support the Science Industry Talk again this year as a cooperation partner. And I am particularly looking forward to the keynote address by Professor Johnson from MIT Sloan School of Management. I've had the privilege of earning several executive certificates at Sloan in Boston over the past few years. In this spirit, I wish us an exciting exchange. And now I hand back to Rosa, please. Thank you.
Thank you very much. Thank you very much, Peter Koren, for your kind words. I'm also very much looking forward to listening to Simon Johnson. We will now listen to Federal Minister of Education, Science and Research in Austria. Please welcome, don't welcome him, but please listen to a video message from Heinz Fassmann.
Mr. Hensinger, Mr. Knill, distinguished guests, I would like to start by thanking East Austria for hosting this important event. You bring together what I hold to be amongst the most important pillars of our modern society, science and industry. Unfortunately, I'm not able to participate at this year's Science Industry Talk, but I really do want to at least express my deep appreciation for the contributions that East Austria has already accomplished in its relatively short existence. I'm really pleased to see how East Austria actively nurtures an atmosphere in which scientific personnel is not only given the room to tackle even the most abstract and novel problems in basic research, but where they are also actively encouraged to explore the commercial and social potential of ideas arising from these projects. I'm always fascinated to see how interesting results appear along the way of basic research, most of the time completely unanticipated, yet always astonishing. Occasionally, the most surprising cases of serendipity occur, which may lead from knowledge to commercial novelties. This is why it is very important that both worlds, science and industry, do not exist in strictly separated spheres. IST Austria provides us with a benchmark example on how the two worlds benefit from each other. At the IST Park, as well as in IST Cube, we can witness how basic research is successfully connected with open-minded and visionary entrepreneurs, bold enough to invest into promising and potentially economically exploitable results. So let me express my gratitude for the great work happening at IST Austria and for the companies and startups that exploit and invest into new findings. Thanks to you, Austria can consider itself an innovative country. Your approaches to technology transfer once more reinforce the commitment of my fellow colleagues in the government and of myself to the building up of IST Austria. As you probably know, a new financing agreement between my ministry and the federal country of Lower Austria recently secured the further development of the Institute until 2036. Bearing in mind the unprecedented success stories of IST Austria so far, the further financial commitment was an easy and relatively easy vote for all political decision makers, and hence the new 15A agreement was unanimously adopted by the National Parliament. With this further public financing, the construction of the campus will be completed by 2036. By then, 150 research groups will be working on campus and hopefully continue to surprise us with ever more creative approaches and innovative findings. For now, I wish you all a fruitful and inspiring discussion. I'm already looking forward to all those further innovations you will certainly surprise us with.
Those were Heinz Fassmann's welcoming words, and we thank him for those. Now we'd want to see what we're actually talking about, what Heinz Fassmann was actually talking about. IST Austria, we have a little movie for you. It's 6 minutes long and it's worthwhile seeing. Watch it with me now.
In just 10 years, IST Austria has become one of the world's leading scientific research institutes. Groundbreaking scientific discoveries have been made, many with the potential to be transformed into successful businesses.
What makes IST Austria special is that our researchers have all the freedom to follow their own scientific curiosity. This was also one of the main reasons why I joined IST Austria. You really can follow your own gut feelings and go a direction where you see the most potential. And this is fantastic. I mean, you never know exactly what you will find in the end, but if there is an interesting finding, we have the means then also to turn this into a commercially interesting application.
It is one of the core missions of IST Austria to generate impact from our research through technology transfer. We have started to build and we are continuing to expand an ecosystem that includes a tech park, a seed fund and various other activities. But above all, we've brought together a great and diverse team that can facilitate that process.
We're there to help people commercialize their ideas, and that means to help them navigate their way through territory which can be a little bit unfamiliar to them. And to help them along the way, we offer, among other things, a special fellowship which is aimed at people who want to test out an idea, to work a bit on the technology, to work on the business side of things, so that ultimately at the end of the day they can consider whether to start a company or not.
As an entrepreneur myself, I know the challenges and the many pitfalls on the way very well. So we discuss with scientists, we try to understand the environment in which they are developing the project, and we want to develop them to a stage where they really can take on money from outside.
Another important part of the ecosystem around IST Austria is IST Cube. It's a technology venture fund that supports and invests in founders and their startups across disciplines and coming from all Austrian universities. We provide capital, access and know-how.
IST Park is a joint venture between Lower Austria's business agency EcoPlus and IST Austria. To guarantee a seamless transition between science and industry, it runs its facilities right next to the Institute's campus. Valanx Biotech is a young startup in the field of synthetic proteins for biomedical applications. It's one of the companies whose labs are located at IST Park in order to benefit from the proximity to IST Austria.
One of the several advantages that we have by working in the IST is the exchange of science and ideas with other scientists that they have expertise that we might not have as a small team that we are. And this can help develop our processes and ideas in a better way.
An open office infrastructure is combined with brand new laboratories and shared research facilities with state-of-the-art equipment.
The other advantage is that we can, of course, use some of the equipment that is impossible to acquire as a small company. So we can just book their technology and basically their machines to use them.
Partnerships with other institutes have also led to exciting technology transfer projects. Solgate is a startup born of cooperation between SEM and IST Austria. The company works on new drugs that target membrane transporters involved in many diseases.
Some of the people around me have been affected by different diseases, and I think trying to think of new ways that could help other patients in the future is something that is very motivating to me. And tech transfer here plays a very crucial part. We work very closely with them. We need their help. We're here to learn from their achievements. We're basically trying to turn things that we find in basic research that is done at SEM or at ISTA and bring it together into a setting where we together build a company. There is something very exciting about developing something new, a new startup, a new idea, taking scientific rigor from basic research and translating that into findings that perhaps in the future can help patients of different diseases.
The support provided by the technology transfer ecosystem allows scientists to concentrate on what they do best.
It's obvious that when you come up with the idea of creating something different or that goes outside from your comfort zone, it's nice to have experts around. And I think this type of support is essential to be able to really do something seriously.
Harold Vladar was one of the first founders to join the IST Park. His company, Ribbon Biolabs, is developing an innovative technology to synthesize long DNA molecules.
3 years ago, I decided I wanted to become an entrepreneur and pursue some ideas for synthetic biology. And IST was supporting me in the sense that they first took me as their incubee in the IST Cube, and later they became one of our investors. My personal motivation behind Ribbon is to create impact, to contribute with a new type of technology that facilitates the growth and development of the industry. Essentially, many regard synthetic biology as the fourth industrial revolution, and I'm very motivated and inspired by contributing to the growth and development of it.
10 companies, from startups to established businesses, already profit from the outstanding infrastructure, access to highly talented people, and inspiring atmosphere of the community in and around IST Austria.
Now, ladies and gentlemen, who could better talk about IST Austria as the head of tech transfer at IST Austria and managing director at Twist GmbH, Markus Wanko. Welcome.
Hello, Rosa. Thanks very much for having me here. It's needless to say, I think, and as charming as it is to have a tete-a-tete with you here tonight, it would be much better, obviously, to have this as a physical meeting and being able to interact with the researchers that we have here and the interested audience.
Having you all here, yes.
I hope
I'll let you speak now.
I hope we can have this next year again. The series is called Science Industry Talk, but since the inception, it was really always about bringing together people rather than just talking. And that's the important thing that I hope we can achieve also in the format that we have this year, and then again in a better setting than next year. The highlights of this evening really are the presentation of 12 specific projects and ideas that you will then see in the separate breakout sessions. Certainly Simon's keynote speech and an interesting panel to follow. But before that, let me just briefly highlight some of the developments that we have had here in the tech transfer ecosystem in and around IST. So what's new? We have new ideas, we have new spin-off projects, we have developed a new spin-off policy, which might sound a little bit bureaucratic, but I think this is also an interesting and important structural development. We have based this on an international benchmarking study. It's published on our website, so for everybody who is interested in this, please have a look. Tom Hensing, in his introduction, already mentioned we have appointed a new vice president for technology transfer. He will wrap up this evening. Bernd Bickel, I'm very happy to have a very accomplished computer scientist and actually Academy Award winner in this role. It's not that I think every institution has an Oscar for this type of activity. On the fund side, the fund that has been mentioned before already, IST Cube has successfully completed the fundraising this year. I can talk a little bit about this. And finally, the tech park from where we are broadcasting tonight, that was opened at the end of 2019, is full. So there are interesting new developments on that end as well. But what are the new ideas that we are talking about? If this would move over to the next slide, it would be nice. Here you go. So basically, some ideas about new projects and new ideas. And what's interesting is that they're really across all the different disciplines that are active here on campus. In life sciences, for instance, a novel concept to treat bacterial infections, or a neurotherapeutic concept based on pulsed light. In digital fabrication, the automated design of casting molds for die casting. In physics, a new idea to stabilize laser frequencies, for instance, and the pretty bold endeavor to join the race of a germanium-based quantum computer. And last not least, in chemistry, new ways to use organic redox materials for batteries. These are just a few examples of the research that's going on here. Some of them might turn into startups like the ones that we have already on campus. You see it on the right-hand side. Two are actually based in the United States, Neural Magic and Gia. These two companies have been based on research that has been performed by two professors at IST Austria. The companies were formed in the US and they are benefiting from the rich, I would say, venture capital scene in the US, and you will hear a bit more about those than in the breakout sessions. The other three companies, Neuralentech, Soulgate, and Ribbon, are based here at the Tech Park and have been partly funded by IST Cube. Which gets us to IST Cube, the fund that was mentioned before. We have successfully completed the fundraising and brought together 45 million euros. I'm very happy about this. We have 20 million from public sources, the European Investment Fund, 6.5 from our sources, public sources here in Austria, and 18.5 million from private investors. And I'm equally happy about both groups, actually. A private commitment, obviously, is a very positive sign of trust. The public commitments from EAF and the AWS and also the region of Lower Austria are the same sign of trust, but they are also a possibility actually for the public to benefit from some returns that are generated, hopefully, from that fund. So out of the 45, we have started to invest 3.7. And just to give you an idea of the scale that's possible, since we are one of the first investors typically in these companies, a further 15 million have been invested by other equity investors, and the companies have been able to leverage grants for another 22. So in total, the 3.7 actually leveraged up to 42 million euros so far. The companies employ 113 employees so far. Well, more men than women, unfortunately. But in terms of nationality, actually quite diverse, as you can see, from 27 different countries, which also highlights the importance of immigration for the work that we do, and the current discussion on the red, white, red card that you're probably familiar with. Last not least, IST Park. I mentioned that the 2 buildings that we have already are fully occupied. So what's next? Another building, of course. We are now in the planning for the next phase. We will have another building with lab facilities as well. Target completion date is in the first half of 2024. And if you're interested, please do reach out. Generally, please reach out to us. I think it's really important to have this interaction. An old-fashioned way is email. You have 3 email addresses for our research activities at IST, for the activities of the fund, IST Cube, and also for the technology park. Well, who is us actually? Well, this is a team of 10 very talented people, I would say. I'm very grateful and happy about their involvement for everybody, and in particular now for Ingrid and Bernhard and Alex, who are actually chairing the different breakout sessions, and you will be able to see them in a minute.
I will come back into the picture now because we're talking about breakout sessions now, right? So we have one more slide with all the 3 breakout sessions, I think. And we can also see the link in your chat. We'll show the link later again, but let's first turn to all 3 of them to say it very quickly. We have computer science, we have life science, and we have physics and chemistry.
Exactly. So it's 3 different streams because it's very hard, I think, to follow all 12 in sequence. On life science, we have 3 professors from the Institute, Matt Robinson, a medical genomics professor here at the Institute, Sandra Siegert for neuroimmunology, and Gaia, who is actually one of the co-founders of 2 spin-offs that we have here at the Institute, Ariel Ben-Simon, who is the CEO and founder of Soulgate. That's the life science track. On the computer science track, we have 2 professors here, Dan Alistair and Christoph Pitschak. The 2 are behind the companies that I mentioned before, Neural Magic and Chia, as well as Lisa and Marcus, the founders of Prewave and Context Flow. And if you are more into chemistry and physics, then we have 2 professors from the Institute, Scott Vaitukaitis, who is a soft matter physicist, and Georgios, who is the gentleman pursuing germanium, as well as 2 founders, Chiara Griganti from Vitra Lab and Daniela Buchmeier from Sakura.
And Daniela Buchmeier will also join us after the keynote speech from Simon Johnson that we'll listen to after the breakout sessions. So the breakout sessions, you can either just click onto the link in your chat, or you go to the website ist.ac.at/SIT. And there you will find 3 different Zoom links, and then you can choose one of those 3 Zoom links and just click on them and you're in. So they're going to start now because it's 5:35 as far as I know, and they'll all be 30 minutes long. So see you all back at 6:05. Have fun. Thank you. Bye-bye.
Thank you.
Okay, so welcome back. What you've just heard and seen was a series of practical examples, whether you listen to life science or physics and chemistry or also computer science. And you've heard about what can be done when science and business and state funding come together and meet up. So the intersection of private and public funding is what Simon Johnson will talk about now. In 2013, the Independent Community of Bankers of America ICBA named him a Main Street hero for his articulate and outspoken support for public policies to end too big to fail. He was IMF's counselor, chief economist. He wrote and co-wrote books like Jumpstarting America, How Breakthrough Science Can Revive Economic Growth, and The American Dream. Over the past decades, he has published more than 300 high-impact pieces in the New York Times, Bloomberg, the Washington Post, the Wall Street Journal, the Atlantic, the Huffington Post, the Financial Times, and so forth. Simon Johnson is professor of entrepreneurship at the MIT Sloan School of Management, which you've heard several times today already, where he's also head of the Global Economics and Management Group. And today he will talk about the role of the state in providing basic funding to research. So please give us your keynote speech. We're all waiting to listen to you.
Thank you very much, Rosa. Thanks for those kind words of introduction, and thanks to IST Austria for inviting me to speak today. I'm sorry that I can't be there in person, but I'm also really impressed by the speed and agility with which you switched to a fully virtual event. I actually attended, Rosa, all of the science talks, all three sessions simultaneously, so my head is spinning right now, but it was absolutely fantastic to really get that taste of the breadth and depth of activity that's going on there. So I have 15 minutes, and then we have a fantastic panel discussion, which I'm really looking forward to taking part in. And I just want to say three things in my 15 minutes. The first is about history. The second is about economics. Of course, I am an economist, so I've got to work that in. And the third is about the future. And I think the future is a lot more interesting than economics, so I'll try and spend most time on that. But before we get there, let's try, I think, a little bit of context around what we're seeing here today, both at IST Austria and in the broader world around the issues that interest us and that we're discussing. So on the historical point, I would like to emphasize that, let's say roughly 100 years ago, this kind of convocation or meeting would have been extremely rare, if not unimaginable, at least in the English-speaking world. So what we're seeing here, and what the minister spoke to us about at the beginning, is a partnership between science, particularly pure science, particularly scientists pursuing questions that interest them, government, because government is providing funding, and government is providing the key umbrella for these activities in terms of intellectual property rights and so on, but mostly it's about the money, let's be clear. And private business and industry, which of course for at least 200 years has been really interested in applied science, the beginning of research and development on an organized activity was with private industry at the end of the 19th century. But the idea that industry would link up with pure science, with the government in the middle, that, at least talking about the American history and the British history that I know best, that was a very strange idea 100 years ago. In fact, the scientists were not sure they wanted the government to be involved. Government didn't really see this as a good use of public money. And private business, frankly, thought of the scientists as being, somewhat living in their own planet and not very useful. That changed dramatically in the middle of the 20th century. Interestingly, and I think this is important, it did not change because some economists sat down and said, you know what, we could get a really high social rate of return on large public investments in research and development. Now, that turns out to be true, and I'll come back to that, but that's not what drove this partnership and what drove what I think we could actually reasonably call an accidental economic miracle or miracle of growth in the post-war period. What drove that partnership was mostly national security and in defense and making war, to be absolutely honest. In the United States, the big transformation in mindset came first with radar, which was a British breakthroughs that were applied and developed in the United States. And then, of course, and let's all reflect on this soberly, the atomic bomb program, in which these theoretical physicists who had ideas that many of them even regarded as crazy 10 years before, all of a sudden demonstrated an incredible destructive power was available and somewhat almost at the fingertips of any government that wanted to get itself organized. So this change in understanding of perhaps it's the physical world, certainly it was physics, but also understanding that the same thing could could apply in chemistry, the same thing could apply in biology, and funding scientists to pursue what interested them through the National Science Foundation, which was created about 70 years ago now in the United States. That was a key transformation in thinking, I think, not just for the United States, but also more broadly around the world. So we established this partnership. The Cold War, honestly, which I'm sure we have many reservations about in retrospect, was a further impetus to support for science in the United States. In the mid-1960s, we spent 2% of our entire economy, our GDP, was spent on science, research, development, funneled through the federal government almost entirely. That was the space program. That was the Cold War. Those were also the inventions that brought you the internet, that brought you big breakthroughs in mobile telecommunications, that began to bring you the big developments came subsequently in human biology. And this is where the economics comes in, which is, even though the impetus for this was from a national strategy or strategic defense purpose, and of course the problem with that is enthusiasm for this kind of approach rises and falls. So from the mid-1960s, the US backed off from its commitment to science for reasons we could talk about if you're interested. From an economic perspective, this turned out to be terrific on two fronts. First is when you measure rates of return, how much we actually get back in terms of output generated. These are extraordinarily high numbers, 20%, 30%, even 50% in many studies as a rate of return from a social perspective. In addition to high rates of return ordinarily, we also get major breakthroughs, as I mentioned, the internet, telecommunications, Human Genome Project. If you look around the world and think about the ways in which it's been transformed over the past 50 years, it's actually quite hard to find something big that changed many things, that didn't have its roots in some form of public support for science, some sort of scientific thinking, vaccines. Think of the technology we use now to fight against COVID. Think of the ways in which we organize transportation with jet aircraft and so on. It's hard to find anything where science didn't have a big impact, and where taking that scientific knowledge and finding ways to apply it, we can call it commercialization. I think it's a very good term. It's exactly what we're talking about today. That commercialization was also played an absolutely key role. So we, for accidental or non-economic reasons at least, we created an incredible machinery and a partnership and a governance structure. This is also really important, and I don't have time to dwell on it, but a governance structure which the scientists enjoy what they're doing and they're comfortable that they have sufficient control. Government feels they're getting a return on their money, and private business also thinks this is absolutely worth supporting. So that brings me to the future and the question of what comes next. And perhaps we should say, and perhaps a conclusion of today's discussions is, from your perspective, that everything is fine and we should just do more of this. And I am very happy to go see your ministers and talk to them about the ways in which countries around the world are making investments. I think there's a ramping up of commitments to science as we look forward. The national security card or concerns are at the forefront again in the United States. I say that with some trepidation because when you discuss China and the role of China and China's investments in science, I think there is a win-win aspect to that, in the sense that there's not, I think, a limited amount of science to be invented, and there are definite advantages to being first. So encouraging countries to compete with each other in building stronger education systems and finding more knowledge, I think, is somewhat healthy, but you have to be careful because encouraging a new Cold War is not, I think, in the interest of anyone here today. So the governments are investing in science. That idea is there. The economic case, I have to say, needs to be made again and again. It has been somewhat forgotten or overlooked, certainly speaking about American politics. People will listen. There is a sufficient bipartisan support to increase science funding in the United States. That was a lot of work. It is in place, and there's not many things that have bipartisan support, as you know, in the United States right now. So I'm somewhat confident that that funding will remain there, and that's good for the overall global ecosystem. But I think there is a serious concern that I want to at least float with you today. Now, this may be a concern from this side of the Atlantic, and you can tell me to deal with it on this side of the Atlantic. That would be entirely fair. But I think there's a question about what we do with science and what we do with technology that is much more salient now than it was in the 1950s, 1960s, or even 1970s. See, if you look back at big technological transformations in human history, you can go back 10,000 years, you can go back 2,000 years, you can go back 500 years. It is not typically the case that big change in technology immediately and always benefit everyone. Now, it was the case after World War II. I think that the science, government, business partnership I was talking about did lift all boats. So that was a very special and important moment. But it's also somewhat unusual. That's not what happened in the Industrial Revolution at the beginning. It's not what happened in the any one of the agricultural revolutions that we've had. Usually some people do well from science, including hopefully scientists and people who are able to take advantage of those new ideas. Some people get left behind or don't fully appreciate the opportunities. And some people actually lose because their previous job goes away, or because they're forced into activities that they didn't previously consider to be desirable, but they have to make a living, or something else changes as a result of the technological changes. In the modern world, we worry obviously a lot about privacy. We worry a lot about control over our data, for example. We worry a lot, frankly, about the entire digital transformation. I mean, everything that's happened since, let's say, the 1970s with regard to data and with regard to our ability to access and manage data is unbelievably extraordinary and really off the charts as a human innovation. And you know, at least through the mid-1990s, many people, including myself, many people around MIT were wildly enthusiastic about the arrival of the internet. And even the first social media companies had people very excited about the potential to strengthen democracy, for example. I don't think that many people are quite so confident anymore. I think there's a lot of concerns about the direction in which technology is going. We in the United States, and also you in Europe, although I think perhaps you've managed this better, but we in the United States have lost a lot of good jobs, a lot of middle-class jobs, a lot of jobs that were available to people who didn't have PhDs. Those jobs have gone away. And while we haven't experienced mass unemployment on a consistent basis, we have experienced we have the experience that many people struggle to earn as much money as their parents did. Many sons, for example, in the past couple of decades, have had a significantly lower standard of living than their fathers had in that post-war period. So what have we done, or what are we doing with technology? And, you know, you might say, and certainly this is a legitimate response, and one thing that we hear quite often, look, Simon, relax. This will take care of itself. This is what happens with big technology transformations. There's always some disruption, but people eventually benefit from these new ways of doing things. Well, that might be true, but how long is eventually? I mean, in the Industrial Revolution, real wages stayed depressed, and many people had bad outcomes for, let's say, roughly 50 to 80 years. That's a long time. I look out my window. I'm coming to you from my home, which is actually in Washington, D.C. There are people in my neighborhood who have signs in their front yards, something that people like to do in the United States to send messages, that say, "We believe in science." Right? There's a backlash against technology. There's a backlash against science in some senses. Obviously, there's a lot of political confusion around the messaging of science. But this is not, I think, trivial, and this is not a fleeting moment. There's a much deeper anxiety about what we're creating. And so my final point is really addressing the scientists who are among us. And I think I would put it, I would put it like this, that laying out the vision of where we're going, explain to people what we're trying to build, talking about the better outcomes that we're going to experience or we can experience. As I floated around the talks just now, that came through very clearly in some people's elevator speeches. It was brilliant. Some people were talking about the technology and talking about other things, the building blocks, which I'm not criticizing, I fully understand. But honestly, who is shaping our vision? Who do you want to shape the vision that you could have with technology? Is it a billionaire who thinks that we should that space tourism is a top priority? Is it a large tech company that thinks what it does with your data is its business and not particularly your business? Or is it somebody, people among us who are trying to build better futures for families, for children, better jobs for people? I know that many of those links are pretty obvious to you, and I know some of you may roll your eyes and say, yes, I mean, that's the process. Everyone should understand that. They don't understand it. It is not clear to most people the way in which the development of science into technology, into commercialization actually helps. That's one. And two, honestly, looking at this from an economic perspective, from a historical perspective, it is not necessarily true that you get good outcomes for everyone immediately from this process. And I would suggest, and this is my last point and my last contention, and which hopefully we can take up with the panel, which is these are our choices. And I think what you've built at IST Austria, and I think what the Austrian government has helped to build and what the Austrian private sector and taxpayers has got behind is absolutely amazing. Let me be clear. I think it's a remarkable achievement. I think you've learned the lessons from around the world. I think you've applied those lessons in a brilliant fashion. I wish more people could learn from your experience and attempt to emulate you, because I do like competition around the world also. But whose vision are we pursuing? Whose vision are you pursuing? Where is that vision going to take us? And you know, I'm an economist who's saying this because I think the economics of investing in science is clear and compelling on a financial basis. But the social impact, who wins, who loses, what we do with it, I think that's up to us. And I think if you leave that to a few billionaires or a few big existing incumbent companies, American or other, or if you let it become a US versus China head-to-head national security type of competition, I don't think you're going to get the kind of world that you want. I think that my last point, Rosa, and I'll conclude. In the 1980s, when HIV/AIDS first, the plague of HIV/AIDS first became apparent, activists in the United States became extremely well organized and put their demands forward in an extremely forceful way. And what did they demand? What was their number one? It wasn't a request, it was a demand, I can assure you. It was more science funding for the National Institutes of Health to pursue an understanding of this, of exactly what HIV/AIDS was, and of course, what could be done to either cure it or treat it. And Anthony Fauci, who's now, as I'm sure you know, an international hero for his work on COVID-19, was in the late 1980s not a hero. He was the anti-hero for these HIV/AIDS activists until he changed his mind and helped persuade the government to change its policies and its vision, Rosa, its vision for what the science and the stock of scientific knowledge could be used, how it could be used, and how it could improve people's lives. And that's just one example. It's a very important example, but one example of what we can and I would argue should do much more broadly going forward. Thank you very much.
Thank you so much, Simon Johnson. I forgot to say earlier that if you want to ask questions, which we want you to do, you can use the Q&A function. In German, it's the Frage- und Antwort-Funktion, not the chat. The chat is only organizational stuff. So use the Q&A function if you want to jump in and ask some questions. I'll ask them for you. I'll get them here on my iPad. So now the CEO of the KNOW Center is with us, Stephanie Lindstedt. She's a computer scientist. The KNOW Center is a leading European research center for big data, artificial intelligence, and data-driven business at the TU Graz. Also with us, Daniela Buchmeier. She was already in one of the 3 Sessions. She holds an MBA in Innovation and Entrepreneurship, as well as an engineer degree in biochemistry, biotechnology, and genetic engineering. She is founder and CEO of Sakura GmbH, a company working on cell therapy. And finally, the CEO of Evotec, Werner Landthaler, is with us. Evotec is based in Hamburg. It's a drug research and development company generating approaches to develop new pharmaceutical products in research alliances and development partnerships with pharmaceutical and biotechnology companies. So may I start with you, Mr. Landthaler, and your perspective on the role of the state and how to support innovation specifically in Europe, because we heard from Mr. Vanko before that there is rich private equity scene, but that's not in Europe, is it?
First of all, thank you so much for the invitation. Secondly, Simon, big thank you to you for your thought-provoking introduction here. And by the way, congratulations to your Christmas mug that I just saw on your table. It looks fantastic. If you drink out of that, I guess it's a Christmas mug that you have on the table there.
Beautiful.
And coming to maybe an initial reflection on what you just said, yeah, and also coming to the platform where we're meeting today, it's about translation. So basically, you are asking the question: who is translating from where to where? So where does this bridge go from the left end to the right end? And I think I can only here target one theme, which is basically my life for the last 30 years. What is basically the end of translation? And that should be the patient in our world. And that's why the focus of the IST on healthcare can only translate towards the patient. And if we take your intro here literally, then I think, yes, there is a lot of technology ongoing. Yes, it's a wave, it's a tsunami of data that we're all in. Having said that, if you look at the last 10 years of drug approvals for the currently 3,300 untreatable diseases, drug approvals did not really go up that much. So you have on average about 30 to 50 new drugs approved that go to the patient, and the rest of a lot of ongoing translational efforts is waste, if you're brutal about it. And if you look at this in more detail, we have one crisis that I really want to highlight in order to make what the state does more efficient to the patient. It's the question, is all the data that is state-funded initiated? So is this basic science really then put into a format that makes it reproducible and usable for industry? And why do I go there? Because in 2014, published in Nature, we all saw that only 70% of all the data published, even in top journals, can be reproduced for industrial use. And that's, of course, a very important point, because I think we have to put at the beginning of a process the question, why do we produce this data? What's the purpose? And how does it then flow into the databases? Because if the use of this data should not be translatability to the patient, then it should be earmarked totally differently, because otherwise we are feeding all these algorithms with a lot of confusion that is multiplied when we try to bring it even much further down the value chain. So this is one key point, is the reproducibility question that we have to answer ourselves. And that's why I think IST is in a fantastic place, because this is a new institute with new governance, with new principles, where a lot of the history behind how data is generated, what's the purpose of data, what's the career path of data, and so all biases can be left out in a completely different way than, for example, very old institutions have to deal with that. So Translating to the patient then brings me to the second point that I want to raise here, also coming back to your input-output equation between governments and the patient here, where we have to see that today, when we look at what the state can do, today 90% of all the drugs that are produced are only efficacious in 50% of the world's population. So also here, when you look at the stratification of where do we put our money and where do we treat patients, it's basically a 50-50 chance that the medicine truly works. And that's, of course, an imprecise industry where you could make the analogy, what if only every second car would drive? That would be not very good for the car industry. But in our industry, this is still the norm. And I think here we should all have a clear goal in mind. How can we improve probabilities of success to be more specific for the patient? And these three criteria, that our industry in translation is way too slow because it takes 12 years to bring a drug to the market. It is way too expensive because it's 2 billion for one drug after 12 years to come to the patient, and it is imprecise. Give us a clear mandate to change things. And when we come to change things, I think we're in the best time ever. And I think the best time of technology convergence is just starting if we learn to share. And if we only learn to share in a similar principle, like we have done this in the last 3 years in fighting COVID, then many of the diseases will be much faster treatable than ever before. Why do I say this? Because historically, we generate data in silos and don't share because of our IP rights, because of our competitive drive that is behind our innovation premiums in this industry. But by sharing data, curated data, we can accelerate the path to the patient, as we have now seen, from on average 12 years down to 2 years, at least for some diseases. And if you bring this equation to bear, then I think we are really at the starting point of how translatability of data to the patient can change lives and societies. And this, I think, is my pledge here, that we should take the examples from COVID R&D, where, for example, Evotec was the platform performing all experiments for 26 companies in parallel, and then sharing all data. Or when we are currently working in neurodegeneration, where we are sharing data, that not everyone is trying to solve Alzheimer alone, but that we are truly starting here in finding novel drug targets or drug pathways, and don't go immediately to our silo thinking, but at least share some point of that. And the third point would be sharing of course, novel data that is our competitive, I would say, data driving our industry forward is very difficult to implement. But if we start very simple, by sharing only data that failed, which our industry also doesn't do, but does very, very slowly. Already by sharing, for example, failed phase 1 data earlier, or failed preclinical data earlier, or failed safety data earlier, we would have massive improvements that we can do. And I think that's really the call for action. And that's, I think, also, I would say, a mission behind IST that I could see as a voice, an unencumbered voice, to say, okay, why not adopting novel working principles in translating data in novel ways, and also here finding novel ways to interact with the industry. And I know, of course, that I'm biased here, but that would be my pledge now to 2 companies that are also here, how you think about that and what we then can do together. And with this, I am more than happy to enter then into the discussion.
Mrs. Lindstedt, as a computer scientist, there's how's the cooperation with big corporations going? I mean, pharma corporates, there are big ones in Europe, but IT corporates, you probably have to really look for them, right?
Well, the real big ones, of course, are US or in Asia. Yeah, on the scientific side, on the research side, of course, there exists quite a bit of collaborations between them. However, maybe let me just explain where I come from, because I'm in a very different setting than what we've been discussing here. So I'm running a center which translates basic research for industry to be really applied. So maybe what you said as applied research to really being the translator. And what we also learn more and more is that in order to be really interesting for industries, we need to do more and more basic research. So we need to go more and more towards the basic side. I'm not so sure if this insight that ROEs out of basic research has the highest ROI is actually shared in Europe. I think it might be shared in the US or in the UK, but I'm not so sure it is shared in Europe. I think this is actually a relatively new thing here to really bringing together basic science and industry. And in my experience, bringing those technologies, big data, AI, data platforms, to companies has only led to very moderate innovations, because companies typically work within their own business processes and business models, and for them something totally disruptive or new is not exactly desirable, so they'd like to keep it as long as possible in the way they know how to deal with it. And so what we experience is when we're trying to put AI and data science into companies, is that we improve processes, we make things faster, quicker, more beautiful, more qualitatively, and whatever. But the real next steps are not taken. And that's why we now started a spin-off initiative at the Know Center. We call it the Spin-off Factory, where we try, as a very small organization, so we have 150 people, we're far away from MIT or IST Austria or anything, to really systematically try to bring out technologies which could be applied in very different application fields. It could be life sciences, or it could be production or anything else. And then basically, trying to interact with people like Mr. Vanko, for example, to see in which sectors these technologies could actually really make a difference and really be disruptive. And so this is our new, it's of course not new in the world, but it's for us a big new step to really say we need to bring these technologies out into the world in a form of spin-offs, because they seem to be a good crystallization point for a lot of interests. So like big companies can join, or also local companies can be part then of the ownership, the stakeholders of such a company. And well, I'm personally at the beginning of this journey, so we now spun out 3 of those companies. We had our first little exit, but so this is a starting point for us to do this. And what I learned the hard way now is to organize such a spin-off factory requires a lot of negotiation with the universities and research institutions behind it, because typically letting go IP rights to a certain extent, or letting a little bit more control go is just extremely difficult, and but required, I think, in the startup environment. Yeah, so I think, I don't know if you have another question or.
I'd like to ask you actually what hinders the takeoff that you were talking about, and the reason you're now doing this spin-off factory is because the next step wasn't easily taken, so they didn't see the goal, or what was the problem?
I think each company has, I mean, they have, well, you deal with people who are working in their own business model, and you're trying to inject new technologies in there. And I don't think this can be happening. You can't disrupt, improve your own business and disrupt it at the same time. So you probably have to then build two business units, or it's separated out in a certain extent. Maybe Mr. It would take you have different experiences. That's my experience with many companies. Maybe it's still possible, but many companies are actually struggling with that.
Daniela Buchmeier has a lot of experience with many different types of companies. She used to work for GEA, not the shoemaker, but the German plant manufacturer. And you also, so you worked as like a corporate innovative role, and you're now funder and CEO of a startup. So could you tell us about your experience?
I think, and then I can align a little bit with Stephanie said, and also with what Benno said, is the big difference between innovation performed in a corporate, and I have to admit that I have just experience in a large corporates, so two American S&P 500 companies, and now in a startup. So for me, the difference is quite obviously, although there may be phases in between. The big difference is the type of innovation to perform. So when it comes to incremental innovation, in my experience, it's relatively easy for an average innovative company, which did not totally become too self-centered and totally disconnected from its market. Usually, they understand what it takes. They know the processes. The problem can be characterized well enough. It's understood what it takes. It's plannable, and the experiences exist. So in those type of innovations, I really believe actually that corporates have an advantage, because I mean the basis is there, the funding is given. The big difference, I think, is then when it comes to disruptive innovation. And although I saw that when shook his head, I agree with Stephanie. I always experienced that the problem is at the end that most people, and therefore also managers, they struggle with this ambidexterity. So on one hand, you're measured on short-term goals and quarterly performance KPIs, and on the other hand, you should perform long-term goals and with a lot of uncertainty and a lot of unpredictability. And I mean, it may be so long-term that you don't even benefit from it. Yeah? So why should you do? And as I had seen in the big corporates, is financially, you benefit from quick wins and not from long disruptive stuff. So I experienced that it takes people who have a quite intrinsic motivation to change things, to do certain things. And for that, I fear in the corporate setting, I didn't see this, on one hand, a long-term vision, on the other hand, the flexibility of the structures, as Stephanie pointed out. You're measured as a corporate on short-term goals. Yeah, so you need to handle that, to conflict with your own goals, to pursue something what is a long-term thing. And I think COVID was a good example. People, ex-colleagues called me and said, "Oh, do you struggle because you're a startup and crisis?" I said, honestly, I've never been in a safer position, because my VCs and my public grants, they don't take back the money or cut costs just to rescue next quarter figures. It's about the consistency, the willingness to support you on a journey. And on the other hand, give you the flexibility to adapt it. I mean, we're trying to hit the moving target. Yeah, if I have to make a 3-year plan and I'm not allowed to change on the learnings we have, it's stupid. Yeah, and this is I experience where at the end I thought or accepted for myself, if you want to pursue that, yeah, and it's probably not the corporate setting you're looking for. So I found it out of frustration, honestly.
So Simon, you mentioned governance structure before, and I'd also like to put in organizational work, because money is not everything, even though it's a precondition. But would you talk about like governance structure and framework as well, please?
Well, let me say first, Rosa, I think Daniela has articulated a really fundamental tension, which we might say is between big corporates and startups, but I think more generally it's exactly as she said, between types of organizations, types of time horizons, an ability to be flexible versus do you have enough backing to pursue what needs to be done. And I think that's that also we can bring that to science and to the case for scientific research and supporting that, Rosa, and the governance piece. You see, I think the reservation, if you go back to the 1920s and 1930s, establishment scientists in the United States they found the idea of government support abhorrent because they said it'll come with strings. They'll micromanage us. They'll tell us exactly what we need to do. And on the flip side, the government people reaction was, yeah, of course we're going to tell you that, because otherwise you'll just be wasting your time. And there is a genre of American politics, and a rather unfortunate kind of politician who revels in finding obscure research on types of squirrels or whatever that's supported by the NSF, and they making fun of it in public as if to say, well, look, this is just trivial and it's ridiculous and so on and so forth. So I think it comes back to what Daniela said, which is, do you have competitive mechanisms for funding, right? Which are national, but also within Europe. I think that's actually a real success of the European system. And do you have proof of the pudding in the eating, as in some of these ideas come out from the science labs in ways that perhaps we could have predicted, but also are unpredictable. I was talking to Tom Hinsiger earlier today, and he said to me, and I'm afraid, Tom, I will be always quoting you on this and not always using your name. So now I'm going to use your name at least once. Tom said that it is impossible to predict what's going to be hot in science 5 years from now. And I think I'm going to add that to the long list of other things we can't predict, like the world economy, US interest rates, who will be president in 10 years of the United States, and which virus we'll be fighting with. But that's okay, Rosa, because I think if we have the stock of scientific knowledge, and if we have the translation mechanisms, and I think Werner, I just take this opportunity to endorse fully what he's saying about reducing the frictions to translation and speeding up the learnings, because that is absolutely, Werner, something we should have learned from the past 2 years. So I think if you have the stock of scientific knowledge, you have the very smart scientists, you have a lot of people in the translation business, and with the flexibility it sounds like Stephanie's developing, that is the magic mix, Rosa. That is what you need. And the governance of that is, it's competition, it's when there's a crisis, do we have what it takes to respond, right? I mean, that was a very big governance check. And I think that, we can improve this, and we can push for better. And I think civil society should be demanding solutions from us and missions from everybody in academia, rather more. I think they're extremely polite, frankly. I think they should be demanding practical solutions, and we push back by saying, look, you have to develop the fundamental knowledge in order to deal with the unexpected and find solutions that you couldn't previously have imagined. And I think that tension, which I see as a corollary to what Daniela said.
There's a question here that I'd like to throw into this round. If I understood Simon correctly, he argues in favor of direct science change, or using science purposefully for economic and societal impact. This is not ISTA's model, which is blue sky basic research. Researchers research what they're interested in. Any economic or social use arises randomly, but with very professional support. Should IST target some of its research?
I think it makes perfect sense for IST to pursue the blue sky model with the, attempting to pull pieces out at every opportunity. I guess my remarks, Rosa, are probably more addressed to civil society and to groups of various kinds who should be banging on the door of Marcus and others, and saying, look, where is, and then maybe they're going in with Werner on this, where is the solution, the progress we need to make with regard to this or that disease that's obvious, the kinds of jobs we want to create, the way we want to share prosperity. Where are you guys on this? And so I think there's a tension, or a dialectic, if you still like Marxism and Hegel in Austria, a tension.
Some of us do.
Yeah, right. And I think that's a very healthy tension. But having blue, look, I think the magic and somewhat accidental economic miracle of the past 100 years, Rosa, was largely about being willing to support and finance that blue sky research and seeing where that takes us. And then, yes, the random diffusion or migration, but let's not be too random about it. And let's also, actually, a very important point Marcus was making earlier that nobody's touched on yet is the capital. Actually, Daniela touched on this. Do you have patient capital? I mean, I have lots of complaints about venture capital in the United States, many complaints. But it's mostly about the fact that their taste is for putting little bits of capital into lots of things, spray and pray, they often call it. So I think patient capital, being willing to back technology that requires longer and needs more money in a longer time horizon, that's really critical. And it sounds like that is part of what IST is doing, and I hope that we'll see more of that in the United States as well as in Europe.
So there's one more question, probably more going, probably also one that you could answer. How can all these inspiring research and innovation activities reach out to educating, inspiring the young and or the public? So here comes in the media as well. For example, IST professors and researchers engaging in talks at schools or universities or similar invitations. I think that's so would that be a smart thing to do, to like go around and have some talks about what happens here?
I think it'd be more than smart, Rosa. I think it's rather essential, particularly at this moment where people have become incredibly confused about, what's good data, what's a probability, what's my risk of disease. There's a great deal of profound confusion about that, which, certainly can be cleared up by scientists. There are many excellent communication professionals around science, including IST Austria, who can also take that on.
Let me just jump in here. I think also here it's the best days in history, because for the first time, tech language is spoken by a wider audience than ever before. So I think using the moment where all of a sudden even generalist newspapers are talking about structural biology, or about AI prediction, or about antigens or adjuvants or mRNA technology, and where people start to understand. And of course, when we also see how much tension science creates and how much conflict science creates, that's the moment to step in and say, let's start the dialogue and let's really get deep in here, because this will be the transformation from a society that either is able to learn and go into a next stage of a society, or to what Simon was saying, to a society where the son and the daughter will absolutely have no chance to have the standard of living from the parents, because it will be the qualification levels to understand the lingo that is coming, if you're part of it or if you're not part of it. And I think that's why this is so important, to close this gap, because someone who is not able to go over this bridge now will be left behind gazillions of years and has no chance to catch up again. So that's how brutal life between innovators and non-innovators will be. And that's, I think, why there's a huge geopolitical, but also society-driven impact behind this question. That's why I think it's an absolute political must to take this absolutely serious.
To close that gap, we have a link for you, and the link is the same that you used for the parallel sessions. It's ist.ac.at/SIT, like sit down and watch. And you can watch all the recorded 3 parallel sessions there. You can even play them in a classroom or hand them out to other people so you can spread the news. Thank you all very much. Thank you, Simon Johnson. Thank you, Werner Landthaler. Thank you, Stephanie Lindstedt. And thank you, Daniela Buchmeier. And thank you all for asking questions. I'm sorry we could not answer all your or all my questions. And now I'd like to ask Bernd Binkel for his closing remarks and wrapping up this whole evening. Thank you very much.
Thank you all for virtually attending the Science Industry Talks, which is an annual series organized by IST Austria's Technology Transfer Team. This year, it took place for the 13th time, and it's actually the first time we had multiple tracks covering computer science, life sciences, and physics and chemistry. It shows that IST Austria is on a good track and growing, and with it, the number of inventions that might actually have significant commercial potential. Our mission as the technology transfer program at IST Austria is to provide the necessary support to identify and realize these opportunities. I hope today's talks have inspired you. Founding a spin-off can really be an excellent way to make groundbreaking research results available to society. And I want to mention here that TWIST, IST Austria's technology transfer program, IST Cube as a venture fund, and IST Park, which offers actually offices and lab space next to our campus, are here to support you to get started on this journey. I would like to thank Simon Johnson for his great keynote, our panelists for the interesting discussions, and all entrepreneurs and researchers who have shared insights into their interesting work today. Finally, I want to thank the organizers, especially Markus Wanko and the great team working with him. With this, I wish you a great evening, day or night, depending on from where you have tuned in, and thank you very much.
Thank you very much, Bernd Bickel, and thank you all for joining us this evening. Stay safe, and stay healthy. If you're not, get well soon, get better soon, and thank you very much for joining us at the Science Industry Talk 2021. Hopefully see you next year. Hopefully not see you online, but in real life next year. Bye-bye.